Good morning, everyone. Today we are going to discuss about the Geographic Information System, that is GIS, basic concept and components and its capabilities. Okay, a GIS system is a design to capture, store, analyze, manage, and present all types of spatial or geographical data. Spatial means it's related to space, and geographical means on the Earth surface data. It is an information system capable of integrating, storing, editing, analyzing, sharing, and displaying geographical referenced information. Okay, there are some key concepts like integrates data. It combines various maps and remote sensing information. Then it allows users to create interactive queries and analyze spatial information and generates models, maps, and visualize for real-world applications. Okay, GIS is a science utilizing the geographic concepts, applications, and systems. A functioning GIS is not just a software, it is an integrated system built upon 5 key pillars. Understanding each component is essential to appreciating the full power of the technology. First of all, hardware, then software, then people, means its user, data, and methods. Okay, first of all, hardware. Hardware is the computer device on which a GIS operates, the physical infrastructure, and it can be anything from large and centralized servers to network or standalone desktop computers. And softwares, it indicates the database management systems, tools for data input and manipulation, tools for geographic query analysis and visualization, a geographical user interface, that is GUI for GIS. And it provides the functions and tools to store, analyze, and display geographic information. Okay, commercial, for example, ArcGIS and InfoMap, noted as most popular, and Intergraph, Map Info, and open sources. So there are some open sources also, QGIS, AMS, and Mars also. Okay, the fuel of the system, data. There are 2 types of data. First of all, it's spatial data and tabular data. Data is the most critical component of any GIS. It can be controlled in-house or acquired from a commercial provider. Spatial data represents the geographic location and shapes of features, forms like maps, satellites, aerial photography, etc. Critical requirement must be properly georeferenced, that is tied to real-world coordinates like latitude and longitude. And on the other hand, tabular data, attribute data that describes the spatial features, relationship linked to spatial data to provide context and details. Management, GIS integrates spatial data with other data resources, often using a DBMS, that means database management system, to organize and maintain it. Okay, after that, there are some peoples and methods. People means the users. GIS technology is of limited value without the people who manage the systems and apply it to solve problems. Technical specialists design and maintain the software. Everyday users, they use the system's outputs to perform their work and make informed decisions, like GIS students, GIS scholars, etc. And modern user-friendly interface allow non-technical users to access powerful analytical capabilities. And methods. Method means the plans. A successful GIS operates according to a well-designed plan and business rules. These are the models and operating practices unique to each organization. Ensures GIS is applied as a systematic, structured approach for solving spatial problems, preventing it from being just a collection of hardware, software, and data. Now, how a GIS sees the world? Okay, we need to understand the model, data model. Real-world objectives like house or river and continuous fields like elevation or rainfall must be represented digitally. And GIS uses 2 primary methods to store this information, raster and vector models. This is the real world, and we can convert this real world into vector model and raster model. Raster model means it includes some pixels with some spatial resolution. Spatial resolution means, suppose this is a pixel, and height and depth of this pixel is known as spatial resolution. And vector model, it includes point, line, and polygon. Point and line and polygon. Okay. Okay, vector model, the world is discrete object description. First of all, information about points, lines, and polygons is encoded and stored as a collection of XY coordinates. It indicates as a XY coordinates. and best for describing discrete features with clear boundaries. And for example, routes and rivers, lines, boreholes, points, or a capital center, administrative building maybe, and soil cells, territories, and property parcels. It's for example polygon. Okay, and on the other hand, raster model, the wall is a continuous surface. Description comprises a collection of grid cells. There are some grid cells we call as pixels, masked like a scan map or photograph. Each cells hold a value that its unique value. Best for modeling continuously varying features. And there are some examples of raster mapping: rainfall amounts, elevation, soil type, satellite imagery, where each pixel stores a reflectant values. Okay, reflectant value means the gray level of each pixel. Okay, there, look at these images. This is a green, this is a light, and this is a dark brown. Okay, each and every pixels has its own reflectance value, and each and every pixel has its own spatial resolution, means its height and width. Okay, it's depend upon the source of satellite. Then this is the 6 major functions of a GIS procedure. First of all, input, then manipulation, then management, query, analysis, and visualization. Okay, let's see more details about this. Functions 1, data input. Before geography data can be used, it must be converted into suitable digital format. Okay, it must be digitized. Okay, it may be in two formats, vector and raster, as I told you earlier. Map points, lines, and polygons, and raster data stored as cells or in a grid system. Okay, the digitizing process can be labor intensive and time consuming, and today many types of geographic data already exist in GIS compatible formats and can be obtained from data supplies to be loaded directly. Then the next methods, data manipulation and management. It perform to transform or operate data to make it compatible within the system. Okay, after downloading the data, we have to transform and prepare data to make it compatible with the system. System means your own laptop or GIS use device. Okay, common tasks, there are scale transformation, projection, and generalization. Scale transformation means integrating maps of defined scales like 1:1, 10,000, and 1:10, 10,000, or 1:1 lakh, etc. by transforming them to a same scale. Projection changes, converting between defined coordinate systems. That means latitude and longitude. And generalization, weeding out unnecessary data to simplify it. The third process is management. To store, organize, and manage large volumes of data efficiently, especially with multiple users, we have to manage data properly, like table 1, table B, table C, or form folder 1, folder B, folder C in your own computer, in your own purpose. And the core tool is a database management system. We can use also database management system, shortly known as DBMS. Okay, dominant modeler, their relational model is highly useful for GIS. Data is stored in tables and common fields are used to link them together. This structure is simple, flexible, and widely deployed. Then fourth and fifth steps in GIS procedures, query analysis. Query means retrieving stored information, both spatial and tabular. The spatial and tabular data will be retrieving in this stage. Okay, the method will be, it can be done via a menu-driven system or a formal language like structure. Query language is like, it can be done via menu-driven the fourth and fifth methods are query and analysis in GIS analysis procedure. First of all, query, it retrieving store information, both spatial and tabular. Then it can be done through a menu-driven system or a formal language like structured query language, SQL. Then examples, questions, where are all the soils suitable for sunflower crops, or what is the groundwater availability in this district. These are some query. Basically, there are some queries we asked in our GIS systems. Then after the query, we can get some answers and we need to analyze them. Okay, the next step is analyze. Purpose, also known as spatial analysis or geoprocessing. This uses the geographic properties or features to look for patterns and trends and understand what if scenarios. And key analytical tools are overhead analysis and proximity analysis. Overhead analysis means the integration of different data layers to create a new combined layer. And proximity analysis means buffering, determining the proximity relation between the features, like them what is, for example, what is within 100 meters of a river. Buffering, suppose this is a center and we need to write, we need to draw a 5 kilometer buffer zone. Then we 5 kilometer radius. This is the, it may be the buffer zone of this center A, and is a 5 kilometer or 5 miles radius buffer zone. Okay, this is known as proximity analysis. Then last stage is visualization, the end result. For many geographic operations, the end result is best visualized as a map or graph or table. And power of maps are highly efficient at storing and communicating geographic information. And modern GIS can integrate map displays with a variety of other outputs to create a comprehensive final products, reports, three-dimensional views, photographic image, and multimedia. These are some visualization, graph, table, diagram, and photos. Okay, to summarize the core of GIS, that means Geographic Information System. GIS is a comprehensive system for working with geographic data. Geographic data means geospatial data, means its location, latitude, longitude, etc. Then define geographical phenomena on the earth's surface. Then map making procedures. This means geographic data, satellite data. It may be satellite data. Then components, it relies on a integration of hardware, software, data, and people and methods. There are 5 basic components of GIS systems: hardware, software, data, people, and methods. Then it represents the world using vector and raster models. Okay, it performs a series of tasks from input and management to analysis and visualization to transform raw data into understanding. By integrating these elements, GIS provides a powerful framework for asking complex spatial questions and making more informed decisions about our world. Okay, this is a basic diagram, GIS core. And after using this hardware, vector, raster, visualization, analysis, query, management, input, methods, people, data, then we get the informed decisions. That means GIS outputs. Okay, that's all for today. If you have any query and doubt, just let me know in the comment section. And thank you for watching. Thank you.